Hey, what's up guys? In this video, I want to take a look at creating a lookup table using Clojure. So let's get started. Cool, so I have a project with a REPL running and I've got this users variable, which is basically a vector of maps, and in each map we have a user map. So say we had the use case where we always needed to query a user here by their ID. So given that we have a list of users, what we can do is we could actually filter through these users. So we could use the filter function over our users, and the filter function takes in a function, and this function will get a user. And then what we want to do is check whether the ID of the user is equal to, let's say we want to look for user 3, which is Tobias. If we evaluate this, let me just evaluate users, then let's evaluate this again. Cool, so once we've done this, we see that we get a list of users back with the ID of 3. So we know that because each ID is unique, we only want the first user in the list, and we can go first. And that gives us our user back. And we could actually simplify this by using an anonymous function. So we could get rid of all of this and use a hashtag, and instead of user, we'll use a percentage sign. And that should still work. And we can also just get rid of this extra bracket, evaluate this, and we get a map back. Cool, this works, but say we had like a really long list of users and we needed to perform this operation fairly frequently. Well, what we could do is create a lookup map. And a lookup map is basically one where the ID of the user would be the key, and then the user would be the value. And this is a much faster operation to look up the user if we know we're always going to have to look them up by ID. So then we could call get on this map and then pass through the ID here, or the key value here, and then we'll get Tobias back. And an operation on a structure like this is far faster than a vector of users. So what I want to look at is converting this vector into this lookup map structure. So I want to show 3 ways in which we can create that. So let's start with the first way, which is by using reduce. So by using reduce, we can reduce our users, and then we need to pass through an initial value, and that will be a blank map. And reduce takes in, let me just scroll down, takes in a function, and this will get our accumulator value, which has the initial value of this blank map, and then each user inside of our list. So we'll get each user back. And then what we want to do is create a map where we take the ID of the user and we map them to our user. What we actually want to do is put this inside of our accumulator. So we can use the into function and pass through accumulator here. And what this into will do is it will combine our new map into our accumulator map. So if we run this, cool, we get that key value map that we wanted. So we could actually just define a new variable here, and I'm going to call this reduce lookup. And we could get from reduce lookup, let's just evaluate that, and we could get from reduce lookup user 3, evaluate this, and we get Tobias here. We could actually simplify this by destructuring this user. So we can go keys, and we want to get the ID, and then we need the whole user again, so we can just say as user. And then here, instead of grabbing the ID from the user, we could just pass through ID and user, evaluate this, and evaluate this, and it works the same. Awesome. So before carrying on to the next method of creating this lookup map, I want to just dive into this into function a bit more. So let's just clear out this. So into is a function which basically combines 2 collections. So let's say I have 2 vectors here, one with A and another with B. If we run this, we'll get one collection with the value of A and B. But if we use map structures here, let's say we had an empty map, and then let's just pass through a map here with the ID of 1. We're going to get a single map where the ID is 1. If we pass through a vector of maps, let's say ID 1, and let's say name is Dan, it's going to combine these 2 maps inside of the single map, and we'll get a single map with an ID of 1 and a name of Dan. And we can also make these vectors themselves, and let's say we'll map this to A, and this one will have a value of B. So these are each individual values. The first value is A, the second value is our map. The second vector has the first value being B, and then the second value of a map. And if we evaluate this, we can see that we get a single map, and now each of these vectors has become a key value pair inside of our map. And that's going to come in handy later. So I'm just going to get rid of this and look at our next way of creating that lookup map structure, and that's by using group by. So group by is a function which takes in a collection. So let's pass through a collection of 1, 2, 3, 4, 5, and then we can group by the result of a function. So let's say we had a function even here, and even can return true or false. Either the value is even or it's not. So if we evaluate this, we can see that we get two keys in our map, one true and one false, and every value that passed the predicate and returned true is in the true key, and every value that passed through the predicate function and returned false is in the collection down to the false key. So let's, instead of using even and a collection of numbers, let's use the ID field on our collection of users. And if we evaluate this, we see that we get a map back where every ID is now a key, and we have vectors where there's only one result in every vector, and that's because our IDs are unique. So we'll have one user in every vector. Now what we want to do is transform this vector, well, just grab the first item out of each of these vectors and bind them to the key in our map. So what we can do is run the map function. So I'm just going to clear this, and we can map over the return result of this, and map takes in a function, and we can destructure the value that we get from this result. So if we destructure, the first value will be the ID, and then that second value is going to be that list of users. So we can say user list. So now what we want to return is a map with an ID, and we want to get the first value from that user list. If we evaluate this, then we get a list back, and we have the maps that we want, but they're within a list. So we just need to get them out of that list and into one single map. And we just saw the function that can help us with that, and that's that into function. So we can go into blank map, and then if we evaluate this again, then we can see that we get the structure that we want. So we can now bind this. We can define a new variable here. I'm going to call this group by lookup. Evaluate it, and now what we can do is we can get from our group by lookup the user with the ID of 3. Evaluate this, and then we get Tobias again. So now the last way I want to look at getting a user is by using the Juxt function. So I'm just going to clear this, and I want to just give a brief overview of what the Juxt function does. So the Juxt function takes in other functions and returns a single function. So let's just pass through plus for now, and let's run plus on the value of 1. And it returns a vector with the value of 1. So it returns a vector where it's applied the plus function to our arguments. So if we add another number here, 2, then we're going to see we have a vector, and inside of that vector we have a value of 3. So that vector is basically running plus 1, 2, and putting that result into a vector here. So what we can do now is add another function. Let's add the string function. So if we run string with 1 and 2, we'll get a string with the value of 12. And now if we run Juxt, we can see that we get plus 1, 2 gives us 3, string 1, 2 gives us 12. And we could do the same thing with multiplication. So let's add another function here. So 1 times 2 will give us 2. So that's basically what Juxt is doing. I just want to show you one function before we continue, and that's the identity function. So identity is a function that returns the value as given. So if we pass through a string of A, identity will return the value A. And I'll show you how we can use that now. So I'm just going to clear all of this, and I'm going to run Juxt with the ID keyword, so the ID function, and identity on one of these user maps. So I'm going to grab this. And here we see that we get a vector back. The first value is 6 because we're basically running ID on this map, and that's going to return 6. And then the second function is running identity, which just returns the value as given, and in that case it's this whole user map. So now we can see that this is kind of the structure that we want to get. So let's map this function over our users. So I'm going to pass through users here and then map here, and evaluate this. Now we see that we have a list, and in each list we have a vector where the first value is the ID and the second value is the map. And if you remember when we were looking at into, we can actually pass a structure that looks like this into a map, and it will create that lookup structure that we're looking for. So if we evaluate this, awesome, you can see that we now have a map where the key is 1 and we get the user associated with that key. So we can actually just make a new variable here. I'm going to define a variable called Juxt lookup, evaluate this, and now we can get from Juxt lookup the user with the ID of 3, boom, and we get Tobias. So that's 3 ways in which you can create a lookup table in Clojure. If you have ways of doing this, please let me know in the comments below. I'm trying to get to 1,000 subscribers. It's a dream of mine to have done that since I was about 7 years old. So if you could help me fulfill that dream, that would be much appreciated. And then I'll try and help you fulfill your dreams of creating data structures in Clojure. So cheers guys. Catch you in the next one.